Why hello everyone. Welcome to our first video presentation for Senior Design 2. Now let me get started telling you about our project. Our project consists of ADC testing in hostile environments. Hostile environments include environments that have high voltage, high temperature, and high radiation. It is important to know when ADCs fail in these environments, since if they were to fail under these conditions when they're used in an invention of some sort, it could cause catastrophic failure, which could possibly mean the loss of human life, for instance, in self-driving cars. Last semester, we picked and started designing our ADCs. This consisted of choosing 3 ADCs from different manufacturers that had our ADCs chosen. We purchased a couple of each variant, and in addition purchased an evaluation board from each manufacturer. Now, the evaluation board is critical for our testing procedure since it includes components that are necessary to power the ADC and to collect data. With all of these devices in hand, and we next had to consider how to actually perform the testing. We didn't want to put the evaluation board under stress because that could damage the other components, so we decided to design daughter boards that would connect to the evaluation board using external connections that are custom designed. And the daughter boards we had to start designing using EagleWorks, which is a CAD software that allows us to do PCB layout. We chose for our purposes 2-layer boards, since this was sufficient for our needs. With this done, we are hoping to send off our evaluation boards to the manufacturer very soon. And then we will move on to the testing phase.
Thank you, Eric. As mentioned, we have been designing 3 daughter cards to test the ADCs in the chamber while communicating with evaluation boards outside of the chamber. While we are very close to sending the final board schematics to be printed, there have been some challenges that we faced and overcome along the way. For starters, some of the ADCs did not have libraries with footprints for them, which meant that the part needed to be made by hand. Also, each of the ADCs from the 3 different manufacturers have slight differences across them in things such as size or dimension of the ADC itself, the number of pin connections to be routed, or different values for the decoupling capacitors, or a different number of decoupling capacitors as shown in the evaluation board schematics. We also needed to make sure that we could find libraries for all of these parts, and that the parts are also available and ready to be shipped by the manufacturer. Another decision that needed to be made was how to connect the ADC to the daughter card. Initially, we thought that we would use a clasp to do this. However, the board designers did not have experience using clasps or designing for them, and also the small size of the ADC itself presented another challenge, so we decided to have the ADC soldered to the daughter card. Finally, we also learned about using copper pores with the board designs to limit impedance, and also about having 2 different ground planes for analog ground and digital ground. On some of the ADCs, the analog pin connections are next to the ground pin connections, and on some of the other ADCs, the analog and ground pin connections are interwoven, which makes it a little harder to have a natural separation for the analog ground plane and the digital ground plane. but we were able to overcome all of the challenges that I've mentioned and hope to begin testing in the next month. And now Taylor will talk about the test setup.
Thank you, Sophia. So as she mentioned, we are just finalizing up the last couple of details on the boards, and we will begin printing them very, very soon here. Once we're able to get those printed and have the boards, we will begin the testing phase of our senior design. And to do so, we are actually working with a lab at NXP Semiconductors, which are providing some of the general equipment, power supplies and such, as well as the temperature chamber for some of the temperature testing. So the daughter cards that we have designed are designed to have just the analog to digital converter and some capacitors and connect into the slot on the evaluation boards that we acquired for each ADC. The evaluation board will do the actual data collection for the ADC based on from the ADC that's on the daughter card. The evaluation board will store the data, which we can then pull off onto our computers for data processing. Next up, Herschel will tell you a little bit more about some of the testing that we're going to do.
Thank you, Taylor. There are two kinds of tests that will be run on the ADCs, static and dynamic. The static testing will involve using a slowly changing, high-resolution voltage ramp of constant slope as the input signal to the ADC. This will allow for characterization of differential nonlinearity and integral nonlinearity, as well as other static information. The second type of test is dynamic. Dynamic testing will allow for a characterization of signal-to-noise and distortion ratio, effective number of bits, and other dynamic attributes of the converter. We are excited to begin our testing.